Welcome to the second mini lecture of our COP 2510 programming concept course. We are still in part 1, which means we are still exploring the fundamentals of programming using the Raptor flowchart interpreter. And we are on module 2, which is going to be focused on conditional statements. So the previous module has been pretty much teaching you how you can manipulate data in the form of values and variables in computer programs. Now we're going to switch the focus to how you can manipulate computation itself. What does it mean to manipulate computation? Well, we finished our previous lecture, our previous module, by stating that most of the work that we would do from now on in this first part is explore different type of statement. We saw the variable declaration statement, we saw assignment statement. Now we're going to try statement which change the flow of execution of a program. A program is based on the idea that every step of the program, every statement will be executed one after the other, a little like you follow a recipe in real life. Well, now let's forget about cooking recipe. Let's imagine that we have recipes that say, well, if you have eggs, then use eggs to do so. If you don't have eggs, then, well, let's use something else to complement our recipe. So this is kind of the very informal way I'm going to introduce conditional statement to you today. Let me grab a pen here real quick. Today, what we are going to do more specifically, we're going to go back one slide first of all. We are going to discuss conditional statement in general, okay, the very basic idea, in fact, of conditional statement. And then our discussion will focus on, well, now we know how to use one conditional statement. What if I have multiple conditional statements in my programs? How do I arrange them relatively to one another, etc.? So we are going to see that just like in electronic, you have a serial arrangement of conditional statement which is possible. Make a test, then a couple of lines later, regardless of the outcome of this first test, make another test. And then you have nested conditional statement, which means we are going to test something. If this condition is true, we are going to test something else. If it's false, we test a third thing. Okay, so we're going to come back onto that, and then we will conclude our lecture for today with a couple of slides on Boolean expression. What are Boolean expression? You probably went through already a discrete mathematics class, in which case you learned already what Boolean algebra is. Well, this is going to be just a reminder for those of you who didn't take this class yet. So we are going to move on, and we're going to start with the first concept of this mini lecture, which is conditional statement in general. So here's the example I'm going to use to illustrate what conditional statements are in a programming language. And once again, I remind you, those mini lectures are going to focus mostly on concepts. Okay, we're going to try to be as general as possible so that everything you learn during these 3, 4, 5 first modules is going to be something you can apply later on to any programming language. So we have a large amount of generality here. One thing I would like also to point out is that as we are going to work through those examples of conditional, etc., we are going to introduce different notation. The flowchart notation that we already worked with using Raptor in our first module, and the pseudocode notation, which is pretty much the same thing. We try to express the same type of program, but instead of using diagrams and flowcharts, we use plain English with a certain formalism that is really informative. Okay, so back to this example. What is it that we're trying to illustrate here? Well, let's consider a very simple algorithm. Let's consider a very simple recipe, between quotes. I want to throw away an empty soda can, and I'm going to have to follow the steps. Okay? Someone told me in order to throw away an empty soda can, you need first to open the trash can lid. 2, you need to drop your empty can in the trash, and 3, you need to close the trash lid. So pretty much the idea of a computer program, the idea of a cooking recipe even really, is that there are steps, okay, there are individual steps, statements, and you are going to execute them in a sequential order, which is one after the other. So the program, the algorithm to throw away this trash can, this empty soda can in a trash bin, consists in executing those 3 statements starting here then moving here, and then finally finishing with this. Well, you can represent this in a multiple diversity of ways. You can represent this as a diagram like this. This is pretty much what we did with Raptor so far. Or you can just write, a bullet item list with the first item is open the trash lid, then drop the empty can in trash, then close the trash lid, etc. Okay, so the formalism you use to represent an algorithm or program doesn't really matter. The IDE is there. Steps executed one after the other. This is very close to what we did in our previous module, alright, where we did computation on variable, we read something from the user, we computed a value, and then we displayed that value on the screen. Well, that's a classical pattern for beginner programs. Okay, you read some data, process it, and then output a result. Well, this is really what sequential execution is all about. Now, what we are going to do, we are going to introduce conditional statement. Okay, we are going to introduce statement that can modify the control flow of the program. What do I mean by control flow? Well, I mean that we have now in our program 1, 2, 3, 4 steps. Okay? Well, they're not going to execute necessarily in the same order every time I am executing my program. Some of them, in fact, are not going to execute every time I'm running this program. Let's have a closer look to the changes we made to this program. Well, we have this diamond-shaped flowchart diagram component now here that is a conditional. Inside of the diamond shape diagram you have, here's the trash can's lid already up. This is my condition, and every time I execute this block, this diagram, this diamond shaped block, I'm going to test this condition. So is the trash can lid already up? I look at the trash can, I figure out that yes, it is already up. So I'm going to execute this statement here, open the trash lid. After that, I will get out of my conditional statement and take the next item in the list, which is a statement drop empty can in trash, which will be followed by close the trash lid. If I go back to this condition, is the trash can lid already up, and I figure out it's false, then in this specific case, I have nothing to do. I just go out of my conditional statement to the next statement in line. So you see, I'm going to change real quick color here to indicate this. So you see what's happening here really is that this whole conditional structure here is one statement. This is the first time we encounter a statement that can contain 1, 2 diagram blocks. So what we saw at the first during the first module in our first lecture was that you can put sequentially one after another statement and they will execute in that order, and you can do computation like this. Well, here consider this. My first statement is, well, do I need to do something about the trash can lid? My second statement is, I will drop my can, my empty soda can. My last statement will, anyway, I will close my trash can lid. So we still have the idea of you decompose a problem into different steps, okay? And visually we represented that so far by a flowchart diagram. Now the only thing we're adding is that sometime when you first analyze your problem, you're going to figure out that here you have to do something and you're not quite sure how to do it. Maybe it's going to be more complicated than just one box on your diagram. After you decide that your first step will be to take care of the lid and then drop the can and then close the lid, you can go back into each of those boxes and you can refine them. Do I need to do something more about closing the trash lid? No. Do I need to do something more about dropping the empty soda can? No. Do I need to do something more about taking care of the lid? Yes. It's not explicit enough. I need to say, first I test if the lid is up. If it is up, I open it. If it is not up, I do nothing. Okay, so this is called the stepwise refinement process. You first start by a very rough draft of all the steps you need to do in your program, and then you go back to each of those boxes in your diagram and you refine them progressively. You add more and more detail, and this is a result you obtain at the end. What the previous slide illustrated is what we refer to commonly as the if-then statement. Okay, if then statement means that there is a condition that I'm going to test, and whether this condition, if this condition, is true, I'm going to perform a certain action. If the condition is false, I will do nothing. Now, there is another variant of the conditional statement, which is the if, then, else statement. And this one allows me to test a given condition, for example, to be consistent with our previous previous program. Is the trash can lid already up? Well, if it is, I'm going to execute this statement, open it. If it is not, I'm going to do another statement. For example, yell, who left the trash open? Okay? Once I'm done executing what is in the then part, that is this statement here, and what is in the else part, alternatively, the execution flow will just go to the next step in my program, which is drop the empty can in the trash, and then close the trash can lid. So we have still the same structure, okay? This here represents one statement that we refine. It's a conditional statement. There is something to test, the condition. There is something to do when the condition is true, and alternatively, if the condition is false, there's something else to do. Okay? So this is a full-blown conditional statement with a condition, a then part, and here inside of the then part I can have like one statement, opens the trash lid, but I could also have as many statements as I want. Okay? And in the else part, same thing. In this example I have only one statement, but I could imagine having more than one statement, like following each other here in this part of the program. Okay? So the idea of the conditional is every time you run your program, depending on whether this condition is true or false, you are going to execute this way, or you are going to execute this way. Okay? So the idea is really relatively simple. Let's discuss a little about notation. This is just here on the right side of your screen. This diagram is just there for illustration purpose. Okay, this is how we represent a conditional statement, for example, in Raptor or in any flowchart notation. So you can have like a statement executed when the condition is true, a statement here executed when the condition is false, and as we said, you could even imagine having multiple on each side. Okay? On your left, what you have here is equivalent written in text instead of with diagrams, and written in what is called pseudocode. The idea of pseudocode is that it's closer to a programming language than those diagrams are, but at the same time it's not as heavy on syntax as a real programming language. We are pretty flexible here, okay? We just use the keyword if, and we write it in uppercase to indicate that we are talking about a programming language construct. We are talking about the conditional statement. If, then we write here our condition, then in uppercase, else, and in between the then and the else, all the statements that need to be executed if the condition is true. Between the else and the end if, which marks the end of my if statement, we have all the statements that need to be executed if the condition is false. So this slide here doesn't bring a lot of new concept. It just tells you about different notation for the same thing. While we will use this notation as I indicated in Raptor, we will use sometimes this notation when I give you exercise. Okay, I will use pseudocode just because it's simpler to manipulate through Blackboard, through text assignment and stuff like that. And we are done pretty much with the first part of this mini lecture. Now, what we are going to discuss is, given the fact that we know now how to use a single conditional statement in a program, we have a good idea of what it looks like, we have an idea of how it looks like in Raptor, in pseudocode, we know what is the intent of a conditional statement. Now what we are going to do is we are going to work on putting more than one conditional statement in a program. And we are going to therefore ask ourselves the question, well, if I have more than one, how do I put them together? Can I put them inside one another? Can I put them one after the other? And what kind of problems does it solve to go either way? Okay, when should I decide to put one conditional statement inside of another as opposed to following it right away? This part of the lecture here is meant to provide you building blocks. Okay, you are learning to program. It's like learning to play chess. The first step is to teach you what are the pieces. So we are talking about iterative statement, conditional statement, etc. And then we teach you how those pieces can move on the chessboard. This is exactly what we're going to do here. When you have a conditional statement, multiple conditional statements even, you can arrange them this way. This is allowed by programming language, and this is going to lead to this and this consequences. So we are really learning the basic, what are the pieces, how can I move them on the chessboard. Is it sufficient to make you a chess player? No, clearly not. Okay? But it is necessary to make you a chess player. So what do you need to do once you review those mini lectures and you learn what conditional statements are and you learn all those basic patterns? Well, you need to go back to the rest of this module and you need to practice. You need to write program, you need to do exercise, and this is going to be what teaches you how to program, how to use those building blocks that are presented in the lecture. So I try to keep the lectures really small, so that you can go back to them and refer to them as a sort of reference. Here are all the ways we can combine multiple conditional statements together. Let me think about this when I am trying to solve a given exercise. You know, it's pretty, if you think about it, it's pretty common sense as an idea that you will learn programming by programming actually, just like you will learn to play chess by actually playing chess. So, let's move on to the next part of this mini lecture. We are going to discuss when you have multiple conditional statements in a program and when you are putting them one after the other. We will refer to this particular arrangement as serially arranged conditional statement. This is what I'm talking about. So this is a pattern that you will encounter, of course, like many times in your programming experience, you know, no matter what language you use, etc. The idea is that you have a first conditional statement here with a condition number 1. Some code that is executed in the case condition number 1 is true. Some code that is executed in the case condition number 1 is false. And then what? Well, no matter how many statements you have here or here, the idea is that once you are done executing the conditional statement, you will branch to the next statement in your program. What is this next statement? Well, in this case, another conditional statement. So this is our conditional statement number 2. And this conditional statement works, of course, the same way. A different condition, okay? Some code to execute when the condition is true, some code to execute when the condition is false, and when we are done, we branch to the next statement in the program, which is, this time, not a conditional statement, but just a regular statement. For example, display some result on the screen, something like that. When you are like trying to read a program, either a program that somebody else wrote or a program that you wrote maybe 6 months ago and you don't really quite remember what you were doing, okay? Every time you read program, one of the essential skills you need to master is the capability to read step by step. Most people are capable after a course in programming to look at some code and say, in a very generic term, this program is doing so and so. But most of the time this is just assumption. Assumption derived from the title of the program, assumption derived by just a result of glancing at the code, etc. Well, this is not what is going to make you a good programmer. What you need to learn to do is to really look at the code statement by statement and understand what it does by executing this code in your head and figuring out what's happening. It's a really important skill. Being capable to read rigorously and with discipline, step by step, a program, like a machine will do, without assuming things and just jumping to conclusion. It's very close to what is required from you when you deal with mathematics. You can maybe, after 10 years working in mathematics, glance at an equation and know already which one it is. But when you are a beginner, when you are learning to do demonstration, you do not skip steps in a demonstration. You go step by step with a lot of rigor. This is exactly what we require you to do when you are programming. This skill is not only useful for you to actually read code, but it's also critical for you to write code, because those students who do not have the rigor to read code step by step are also those students that who, when they write code, are unable to actually write accurate code because they lack, once again, this discipline, this rigor to be like concentrating, focusing, and working pretty much one statement at a time in their head. Okay, so I'm not saying that you don't need to have a big picture about the intent of the program. Of course you need that, but when you program, the activity of programming requires you to work at a lower level. Okay, back to this example. What can I do with this example to try to give you some of those skills? Well, when you have a piece of code like this one, and it's really a generic piece of code, it doesn't do anything, we're just talking about condition, code that is going to be executed. It's kind of a map of some generic piece of code, okay? When you have such a diagram to understand, what I would suggest you do is consider what are the different flow of execution inside of this diagram, okay? What will get executed depending on the value for condition 1 and condition true. So let's write this to start off with. Condition 1, condition 2. Each of these can be true or false. Okay, so we are going to kind of derive a miniature truth table for this code. Condition 1 can be true or false. Condition 2 will be true or false. And we have like 4 possibilities for combination. Okay? True, true. Condition 1 and 2 are both true. False, true. True, false. And false, false. So we enumerate all the possibilities. Okay? Of course, as there are more and more conditions in your code, this is going to get like more awkward because you have more and more possibilities. Okay? It's an exponential number of possibilities given the number of conditions. However, in this little diagram, it's relatively easy. So we can start by training and honing our skills for reading code in this kind of formal way. So we have 4 possibilities in this whenever this program executes. Condition 1 can be true, condition 1, condition 2 can be true or false, etc. So let's see what happened in each of those cases. And I'm going to look for something here to allow me, sorry about that, to allow me to erase first the inking that I've been putting here, and then represent the different execution path inside this code depending on condition 1 and condition 2 being true or false. So I'm going to switch to something that is a little more visible, like a highlighter. Okay, let's start with our first example. Condition 1, let's assume it's true. Condition 2 is true. What happened? Condition 1 is true. We execute this part here of the code. So we execute code number 1a, and then we branch to the next statement in the program. So if we want to write this down here, let's execute code number 1a first. Then what? Then we branch into the next statement, which is condition 2. Condition 2 is true as well in our first hypothesis, so we are going to execute this part of the code, that is code number 2a. So we go back here and we are going to write that after code 1a we execute code 2a. And we have here the execution path followed in our code, given the assumption that condition 1 was true, in this case, condition 2 was true. So it's obvious probably to all of you, but when you write 10 pages of code, a program that is 10 pages long, you are going to realize that when you run it, when you execute it, because you have conditional statements in it, not all of your code will be executed. This is where the analogy between computer program and cooking recipes kind of falls short. Okay? In a cooking recipe, if there are like 30 steps on that cooking recipe, you will have to go through those 30 steps. In a computer program, not necessarily true, because we have conditional statements all over the place. So conditional statement tells you that given this and this circumstance, you will execute this and this part of your code. Let me erase this inking, and we are going to do the same job for all the different possibilities inside of this truth table. So we have our first execution path. What's next? Well, the second possible execution path here is condition 1 is false. So I'm going to execute this code like so. So we're talking about code 1b. Then I branch to the second conditional statement, which is true. I'm going to execute this code, which means code 2A. And of course, one thing I didn't indicate here, and I forgot it in the first example, is that no matter what happens, I will execute code number 3. Okay, in every scenario, because this is the first statement, conditional, this is a second conditional statement, and this is the third one which executes no matter what. Okay, so I have here my second trace, my second code trace. I'm going to erase those marks once again, and we're going to move to the third one. The third one is going to assume a couple of problems with this menu. The third one is going to assume my first condition to be true, that is execution of code 1A. And then my second condition is false, which means execution of code 2B. And then, of course, code number 3. Last one, going to erase those execution path. Last one is telling me that I'm going to have my first condition false, which means execute code 1B. My second condition is also false, which means execute code 2B. And you see this diagram, I use this kind of diagram because it's really generic. I'm not talking about a specific real-life example, like throwing away soda cans. I'm not talking about a specific program, like computing, the radius of a circle or something like that. No. What I'm talking about here is a generic code pattern, when you have two conditional, one after the other. Okay, so I know that this is going to throw some of you off because it's really abstract, but this is the purpose of those mini lecture. Present information in an abstract way, so that I'm going to make some of you understand immediately, and the others are going to be a little bit more confused. Then the next step is we approach the same problem for exercise in a much more pragmatic way. And this time the people that like abstraction, maybe I will be a little less interested, and the people that like pragmatic explanation will be captured by looking at the live coding video for the exercise, and this is how they're going to learn. So once again, this module and this lecture, generally speaking, is trying to reach out for different learner style. So when a segment is not really your style, please bear with me, and then we'll move on to something else that is going to probably be a better fit for you. So we have now this code example on which we work like in every other possible way. Let's move on to the next step. The next step is we discuss one of the possible arrangement of conditional statement, having them one after the other. Okay, so no matter the outcome of the first test, the second test get processed and etc. And the second possibility is to nest into one another conditional statement. So what does it mean to nest conditional statement one another? Well, let's have a look at this code pattern here on the right. Once again, a very generic code pattern. Okay, we have 3 conditional statements inside this code pattern. The first one, here is a condition for it. This conditional statement is all of this code. Okay, there is a then part, which is itself composed of a conditional statement, and an else part, which is itself composed of another conditional statement. And then, like in the previous example, we have another statement here, which can be an assignment, a display, an input operation, which is standing by itself. So, let me erase all of this marking. How do we go about understanding what this code is doing? Same thing than before. We are going to pretty much make a mini truth table, telling us, depending on condition 1, condition 2, and condition 3, what is the outcome of this program. That is, which code indicated in this diagram in yellow boxes are going to be executed. So this is going to be a larger table. Okay, we have all the possibility. C1 can be, condition 1 can be true or false. Okay, depending on its value, we can have condition 2 true or false as well. I repeat, true, false here. And depending on all of those conditions, I can have condition 3 being true or false. I'm not really detailing a lot of things about how I build those tables, etc. because first, I'm assuming that this has been done in computer organization or discrete math or other course that you have already taken. If you didn't take them yet, then you will have an opportunity to learn those things in much more detail. I'm trying here to just give you a summary for those that didn't took those course yet, and to give you just a gentle introduction for those of you who need a refresher, for example, or something like that. So we have a bigger truth table here, and the outcome is that in every case, code number 3 will be executed. So now we're trying to figure out what happens here, okay, what happened inside of this huge nested conditional statement. We refer to them as nested conditional statement. You will have some people also use the term cascading conditional statement, and it's really easy to see why, okay, because execution cascade between all of these. So let's go back to our methodology for understanding code, okay, and let's try, we're going to run just a couple of examples. Okay, let's start by the first example. The first example indicates that condition 1 is true, condition 2 is true, condition 3 is true. What happened in such a case? Well, I evaluate condition 1. Is it true or false? It's true. So I go to this part of the code. Condition 2 is true. So I go to this part of the code and then I branch to whatever is after the whole if statement. Well, what got executed? Code 1a got executed. You will notice that even though in this particular instance of running the program condition 3 is true as well, I didn't really care, because the way that my program executed is starting here, move here, use condition 1 and condition 2, execute this code here, go back, execute the code number 3. So the final outcome is that code 1a got executed, and then code number 3, and we are done. Okay? So this is introducing something new compared to the previous example. Let me clean up a little my diagram. Now we're going to pick another example, and we'll do that just for a couple of them, okay? Because of course this is going to become really repetitive after a while, but I really encourage you at home to take this slide and to work out all the possibilities, just as a training drilling exercise, okay? So let's take another one. For example, let's take this example. First condition is true, so I start executing my code. Condition 1 is true, I execute here. I find another conditional statement. I test condition 2. Is it true or false? In this case, my chosen example indicates to me that it's going to be false. I execute code 1b, and then I execute code 3. So the outcome is I execute 1b, and then I execute 3. And you will notice once again, condition 3 was not even tested. Okay, even though in this example I chose it to be true arbitrarily, in this execution, the code that is here was not even used at all. For that matter, the code that was here didn't get used at all ever, did it? Okay, so I'm going to erase once again. There we go. And we're going to test yet another example. Let me get back a pen. Let's take this example here. Condition 1, according to my table, I'm assuming this time it is false. Condition 2 is true. Do I care really? No, because I'm not going to even execute anything that has to do with condition 2. I'm just going to go in the else branch of my main if, and I'm going to bump into another conditional, which is going to evaluate condition number 3. Condition number 3 is false. This is true, this is false. I'm going to execute this code and then code 3. So I got code number 2b executed. Code number 2a was not even considered. Okay? Outcome of this path of execution, 2b got executed and then code 3. And that's all there is to it. Okay? If you can follow your way through a diagram, you can follow your way through a flowchart representing a computer program. If you can do that, you increase your chance to be capable to program with Raptor or any flowchart-based programming language, visual programming language. If you can do that, you increase your chance to be able to do the same thing with pseudocode. Okay, it will take you just a little bit of adaptation once you understand the flowchart diagram to be able to move on to any text-based representation of a programming of a program in a given programming language. Java, for example, C, C++, Visual Basic, or even our Pseudo code. We have been covering now two different aspects, okay, of conditional statement application, I should say. One was, how do I use multiple conditional statements when they are one after the other? The second was, how do I use them when they are one inside another, the nested arrangement, the cascading, so-called cascading arrangement. We are going to conclude this lecture by discussing how we can manipulate those conditions, how we can write condition in a computer language, and this is going to open us to the topic of Boolean expression. You all know what an expression is by now, okay? If I assign to variable a the result of computing 2 plus 3, this is a mathematical expression. The programming language is going to evaluate it into a result, and then this result will be assigned to the variable a. This is an assignment statement. Okay? Well, what are Boolean expressions? Boolean expressions are expressions, you could say mathematical expression, that are going to result in a value which is always true or false. So you can see it as a subcase of a general mathematical expression. What kind of expression can result in true or false? Well, comparison, for example. So this slide is going to give you a couple of examples. On the right, you have just a conditional statement, just like the ones we have been playing around with so far. The condition that we use in such example were real world type of condition, like if you were trying to give direction to someone, like if you were giving them the equivalent of an algorithm, a program to follow to achieve a task. Okay, well, this is plain English here. Condition is illustrated as plain English. Now we need to move on to what we can do with a real programming language. Okay, well, you can do things such as the one indicated here. You can do comparison. So the signs that you can use are lesser than. So if this is a condition representing the test if A lesser than B, and it can be true or false. You can use strict comparison with lesser than, you can use or greater than. You can use inclusive comparison, lesser equal or greater equal. So don't put a space between the greater or lesser sign and the equal. Okay, it all goes together. It's really one operator in most programming languages. Okay, so, and then you have, of course, you have the possibility to make comparison between single variable, like A lesser than B. You have capability to make comparison between entire mathematical expression. So is 3 plus A lesser than B divided by 10? Okay, that would be a valid comparison as well. So besides the greater equal, lesser equal sign, what else do you have? Well, you have the comparison of equality of two values. For example, you can test whether A and B, the content of variable A and B, are equal. How would you write this? Well, this is getting a little bit more complicated because depending on the programming language, you have different syntax possibilities. For example, some programming language, very few nowadays, are going to use the sign equal to test the equality of two different mathematical expressions. Some other programming language are going to use the double equal sign. This meaning equality as opposed to this here meaning assignment in that case. Okay, so you have different possibility. At this point, I want to keep those lectures very, very general. So I'm not going to go into much more detail. I'm just going to tell you what you can do in a comparison. And then you will have to figure out every time you learn a new programming language, how it is exactly from the syntactical point of view that you write the equality between two values. Let's go to the next slide. What's in a conditional expression? Well, the example I took in the previous slide were conditional expression which had only one term, okay, one test inside of them. Well, you can do, of course, this kind of expression. You can also have expression like this one, which has a first comparison, another comparison, another term, and these two terms are linked together using a logical operator. What are the logical operators that are available in every language? Logical AND, logical OR, exclusive OR, and negation, logical negation operator. Once again, you have a discrete math course with some Boolean algebra, you have a computer organization course, you're already familiar with that. If not, I'm going to give you the basics, pretty much of what you need to know to be able to program. The idea is that when you are using several terms, as many as you need, as many as you want, connected by logical operators, you are building a Boolean expression that is just a little bit more complex. Okay, to be able to evaluate if, for example, A lesser than B is true or false, you just need to look at the value of A, the value of B, and compare them. Okay, to be able to evaluate if A lesser than B and A greater than 0 is true or false, you need to first examine A lesser than B, determine if it's true or false, then determine if the second term of this Boolean expression is true or false, is the value inside of variable A actually greater than 0 or not, and then you will have two true value. One for this expression, true or false, one for this expression, true or false. You need then to look at the AND logical operator, and depending on the value of the left and right expression, determine what is the truth value of the whole expression. So this is when things like truth tables comes into play, and we're going to go a little over that. Couple of remarks, couple of warnings. Once again, the lecture is very, very general. Never assume that when you write if A lesser than B and A greater than 0, the programming language will first test this and then test this expression. Never assume a particular left to right or right to left evaluation order. Look up at the specification of your programming language to determine what way this particular programming language operates. Do not assume ever lazy evaluation. What is lazy evaluation? The idea of lazy evaluation is if you write if A smaller than B, lesser than B, and A greater than 0. Well, for this whole expression to be true, you need actually both terms to be true. Okay, you need to have A lesser than B true and A greater than 0 true as well. It's pretty common sense here, okay? So what happens if you look at A and B and you determine that A is actually not lesser strict than B? Do you even need to look at the second term? Well, not really, because the AND logical operators requires you to have both operands true. Okay? So if you figure out the first one is false, why bother? Well, this why bother attitude is called lazy evaluation. It's called the programming language will not look at the component of a Boolean expression that are not going to change the outcome of the evaluation of the expression. Okay, once I know that A lesser than B is false, well, there's nothing I can have here for the second term that is going to make the whole expression true. So I just drop it. Some computer language do that. Some computer language do not do that. Once again, do not assume anything about lazy evaluation before to refer to your programming language documentation. Okay, some language will drop evaluation after the first term, some will not. At this point, it might seem a little confusing to you why this would matter. We are going to discuss that probably when we are attacking the chapters of the textbook in the second part of this course, where we'll have opportunity to realize that sometimes the condition in a Boolean expression are not just mathematical expressions that result in true and false. Sometimes they result in true and false, but only after doing something, like displaying something on the screen, etc. So when we come back to much more complicated program that involve that kind of situation, we'll have an opportunity to discuss, well, is it important the order in which we evaluate the terms of a Boolean expression? What does it change in the meaning and the effect of my program, etc. Just keep it in mind as a warning for now. Concept of truth table. Well, this is relatively easy. I just want to give you a gentle introduction here on this topic. There is one operator here, by the way, that is missing, the exclusive OR operator, so we'll talk about that later. The AND operator, the logical AND operator, the logical OR, and the logical NOT and logical XOR, exclusive OR, are the four basic logical operators that we're going to use in our programming. Okay, so let's take for each of them an example of expression, and let's figure out how we determine the truth table of this expression, which means, depending on the value of each term, what is the outcome in each case. Okay, so here is how you build a truth table. Let's take the first equation. To determine if this whole Boolean expression is true or false, I need to look at the first term. Is A lesser strict than B? This can be true or this can be false. Is A greater strict than 0? This can be true, this can be false. So I have two operands in this expression, each of which can be true or false. Let me determine the outcome of the whole expression depending on the value of those operands. So I'm going to say this is a truth table for my expression. It has an AND operator. Okay. My first operand can be true or false. My second operand, which is here, can be true or false. And there we go. I have here a very simple truth table. 4 possibilities. So what this truth table is telling me is, depending on the truth value of the first operand and the true value of the second operand, what is the outcome of applying an AND logical operator to both of these? My little Boolean expression here is very simple. 2 operand, 1 operator. So building this truth table will pretty much tell me what is the outcome of this particular expression. I could have expression that involve multiple terms and multiple Boolean operator, in which case I would have to refer back to those truth table, the truth table of AND, of OR, of NOT, and XOR, and figure out the expression by itself. You will have, in the second part of this course, we are going to revisit all of those concepts in the context of the Java language itself. You will have opportunity in your textbook to find couple of exercises here focused on strengthening your understanding of the concept of truth table. In this first module here, we are going to just get you the basics of this idea. Okay? So back to our example. What happens if the first operand is true and the second is true? Well, the logic of an AND operator means that both operands must be true, so that the outcome of the whole expression is true. For example, if you say to someone, do you want cheese and dessert? Well, this is going to be true. They do want cheese and dessert only if they want cheese. First term is true. And they want dessert. Second term is true. So this is what the outcome will be here. If any of the term is false, for example, we have here false and true, the outcome is false. We have true and false, the outcome is false. If both of the term is false, of course, the outcome will be false as well. What about the OR logical operator? Let me do real quick another truth table. True, false, true, false. What is the logic of this operator? The logic is that the whole expression, the whole Boolean expression will be true if either of the operand is true. So when I have one operand true and another true, of course the expression is true. If one of them is false but the other is true, we've got true. One of them is true, the other is false, we've got true. If both of them are false, on the other hand, well, there's nothing to do here. What is the logic of the not operator? This one is very easy. This one takes only one operand. Okay, all the other operators are binary. This one is unary. If my operand is true, the result of doing a negation on it is false. If it's false, the result of doing a negation is true. I'm going to add real quick somewhere here the XOR operator. Let's say that I have A lesser than B, XOR A greater than 0. Okay, this is my XOR truth table. True, false, possible value for the first operand, true, false, possible value for the second operand. The logic of the XOR, if you want to remember it easily from an informal standpoint, an informal perspective, the XOR operator asks the question, are my two operand with two different truth value? So every time one operand is true and the other is false, the XOR outcome is true. If one is true and the other one is false again, the outcome is true. In any other case, the outcome is, whoops, sorry about that. Let me go back to the slide. In any other case, the outcome is false. What is the idea of the exclusive OR in a more logical framework? Well, the idea of the exclusive OR is you will have the choice between cheese to complement your meal or dessert. Notice that in natural language we use the same word, or. Do you want cheese or dessert? That can mean two totally different things. That can mean you can have one, the other, or both. This is the meaning of the traditional OR operator. XOR mean you can have one or the other, but not both. And this is what is represented here with this truth table. Okay? One of the operand can be true, but the other one need to be false. One can be false, the other one need to be true. If both are false, then the outcome is false, just like for a regular OR operator. If both are true, then this time the outcome is false. You cannot have cheese and dessert. Okay? Alright, so that's the idea of truth table. One of the difficulties you are going to encounter is when you write conditional statement, and in the next module when you start writing loop statement, you need to pay particular attention to the logic of your condition. It's really easy to write conditions that are always false, conditions that are always true, conditions that do not represent exactly what you want them to represent. The difficulty you are actually encountering right now is the difficulty to formalize things. You are going to encounter a lot of people that tell you, well, I can solve problem, but I cannot write a program. So what is wrong here? Well, if you tell me that you can solve problem, that means that you can find a solution to a problem. If you tell me you cannot program, in most cases it has nothing to do with the syntactical difficulty of the language. A lot of people like to say that they cannot program using Java or C just because the syntax is so weird. The syntax is easy to learn. The syntax is a matter of learning by heart a set of convention. This is not your problem. What might be your problem if you cannot formalize a solution is exactly that, the manipulation of a formal system. Like, for example, a computer program notation or a mathematical notation. Okay? It's saying that you can solve a problem, but you cannot write an algorithm for it, a flowchart, a pseudocode, etc., with correct Boolean expression in the condition, means that you understand mathematics, but you cannot work on equation, which is going to be like a problem for you to become a mathematician. Similarly, if you can have a superficial understanding of how to solve a problem, but you cannot formally produce a solution for it, you are going to have tremendous problem working as a programmer. So this is what you need to invest your efforts in, and everybody has to invest efforts in that specific aspect at the beginning. You need to force yourself into formalizing solution. And as we progress here, I'm going to try to show you tricks on how to read a program, how to trace, the value for a condition, figure out when it is true, when it is false, etc., and if that really makes sense with what you intended to write. Okay? So these little tips are things that you need to practice on. A couple of advice. Well, I think we already went over all of this, okay? Do not assume anything about left to right evaluation, lazy evaluation. These are advice that probably are not really useful for you right now, but that will become useful later when we go back onto the Java programming language or when you go to another programming language of your choice, okay? So I'm going to leave that slide at it for now, and we're going to move on to the next slide. The couple of slides that are coming up right now have a different purpose. We have been discussing Boolean expression. Okay, what does it mean for a Boolean expression to be true? What is the semantic? That is the meaning of the AND logical operators, the OR, NOT, and XOR logical operators. And now we're going to discuss something different. We're going to discuss pretty much what happens when you have multiple operands, multiple terms in a Boolean expression. Well, we already use that, okay? We use the AND operator. For example, here you have an expression that is composed of two terms. Well, what does that mean to introduce a more complicated condition in conditional statement? Why would we want to do that at all? Well, let me show you an example. I'm going to switch color real quick here. Let me show you an example here. This is a flowchart diagram. If A is lesser than B and A is greater than 0, then I display OK. Otherwise, if either of these is false or both of them are false, I display KO and I go to display done in any case after my if statement. This flowchart is equivalent to this pseudocode notation. If A lesser than B and A greater than 0, display OK, display KO, display done. And this is my if statement structure. Okay? Well, this code is really easy to understand. Okay, it's relatively compact. But I've been using a Boolean expression with two terms and an AND logical operator. Let me try to remove this AND logical operator. Can I rewrite my program differently without using the AND logical operator, but instead using two different conditional? Well, the answer is yes, and you will find out that programming is considered by many people as an art form rather than a science, because there are different ways to write the same thing. There are different ways to write programs that do the same thing. And I'm not even talking about using different languages. I'm simply using the same language, but two different programmers will come with two different solutions that are both perfectly correct. And then it introduces the idea of elegance of the solution. Not exactly how pretty is your solution, but how beautiful from a conceptual perspective it is. Is it shorter? Is it the shortest we can do that still do the job? Is it easy to read by over? Is it easy to understand 6 months later when you will have worked on completely different topics and you want to come back to that particular program? So there are many dimensions to the computer program beside correctness. Okay? This slide, even though we are still dealing with simple things, illustrate this idea for you. I'm rewriting the same code. I want to keep the same semantics, the same meaning. When condition A lesser than B is true and condition A greater than 0 is true, I want to execute the same code. So we're not talking about changing intent. What you have here is a flowchart diagram on the right and the pseudocode on the left. What do you notice? There is here a if statement that is nested inside of the then part of another if statement, which is right here. So we made our code a little bit more complicated to achieve the same goal, because we didn't want it to use a complicated Boolean expression. Let's have a look at how it works. First, I test A lesser than B. Just as a reminder, I'm going to write here what was our original Boolean expression. Was it lesser? Yeah, no, it was greater than 0. That was our original Boolean expression. Now what I'm doing? Well, I'm saying if A is lesser than B, true or false? Let's start by false. If A is not lesser than B, I know already that my Boolean expression would result in false. So I do here what I would do in my previous slide when my Boolean expression was false. I go back one slide. If this Boolean expression is false, I display KO, and then I go to done. Well, this is what I'm doing here. I display KO, and I'm done. I just implemented a form of lazy evaluation, didn't I? I test the first term of my Boolean expression. If it's false, I shortcut everything. I don't even consider the second one. Let's take another example. What if, and I'm going to remove some of my marking here to make the slide a little clearer. What if my first condition is true? In this case, let me erase some stuff again. In this case, I am going to go through this execution path. What do I find? I find another test. If my first condition term is true, then I'm going to test what about the second? Is a greater than 0 strict? Yes, no. If it is not, here's what would have happened in my original Boolean expression. First term is true, second term is false. Outcome is false. I go back one slide. When the outcome is false, I display KO. Go back to my current slide. This is false here. I'm going to display KO and then display done. So you see my program really has the same sense, the same meaning, the same semantics. Last possibility. My first condition is true. My second condition is true. I'm going to follow this execution path here. First, go to the next conditional expression, then display OK, then display done. So I've been making a trade-off here. Okay, the trade-off being between the complexity of the code. You see that this code has nested conditional, the previous didn't, and the complexity of the condition. My conditions here are really easy. They are just like one comparison. In the previous example, it was a little bit more complicated. It was a Boolean expression using the AND operator. So, once again, different ways to do the same thing. For some of you, this structure is going to be really complicated at first sight, okay, for the first couple of weeks. So you are going to tend to prefer maybe to use complicated Boolean expression instead. For some of you, for others, the Boolean expression is going to be really complicated to understand, and you are going to naturally break down all of those conditions into a pattern which looks like this. Okay? No matter which solution is easy for you, and which solution you are going to therefore prefer to use, I want you to learn to do both. Because you won't always have a choice when you program. You need to be able to do both ways. And when you read other people's work or when you collaborate with others to develop software, you will have to adapt partially to the programming style. So it's like saying, I have difficulty spelling words with X in them, therefore I'm going to learn my alphabet, but I'm going to skip the letter X. Doesn't quite work that way. Okay, we want you to learn to program, and we want you to learn to program in a way that opens you perspective to work with others and use other people's code. Some of you will never program again. Some of you will probably never write code in cooperation with other programmers, but just download code from the internet, use it for a specific scientific application or business application. Well, when you do so, you need to be able to understand this code. Therefore, you need to be able to read other people's code, regardless of their preferred programming style. Let's go a little further. We illustrated what happened with an AND operator. What about an OR operator? Same situation, okay? Same type of scenario. We have here a condition in a conditional statement that is composite. It has an OR logical operator in two terms. When this is true, I display OK. When this is false, I display KO. And then I display done. Well, let me go to the next slide. The next slide is illustrating exactly what happened with this program when I try to rewrite it differently. So once again, I trade the complexity of the logical operation for the complexity of the overall structure of the program. I have now nested conditional. So if the first term is true, and I'm going to once again remind you here of what was my original condition, my original Boolean expression. If the first term is true, it's a logical OR operator. So I'm doing, once again, a shortcut here. I'm doing lazy evaluation if you prefer. I display OK. I know that the whole expression is going to be correct. Now, if this first term is false, I'm going to execute another conditional statement. If this one is true, then both of them are true, and I display OK. If this one is false, then we have one true, one false. And if this one is false, we have a first term false and a second term false. I'm going to display false. I'm going to display KO. Do whatever I have to do when this whole Boolean expression is actually false. And then I display done. So I'm going a little faster on this example, but this is really similar to the previous one. So I invite you to rework it, outside of lecture class time. It's really important that you understand those examples thoroughly, okay? The lecture do not have many slides, 21 only in the case of this session, this module. So it's meant for you to work and work and work on them again and again until you understand everything, okay? So we have once again a similar trade-off. What about the exclusive OR? This is going to be once again the same story. I start with a program that is really, really compact, okay? I have here an exclusive OR operator between two terms in my condition. I display OK when this condition is true, KO when it's false, and then I display done. I can trade off the complexity of this Boolean expression by introducing nested conditional statement. And you see that this is like by far the most complicated we dealt with so far. We have 3 different conditional nested into one another. This is one conditional nested in the then part of this conditional here, and another conditional nested in the else part of the main conditional. So, what happened? The XOR logic is, well, the 2 terms of my XOR expression. Once again, let me rewrite it here. A lesser than B XOR A greater than 0. The idea is that when one is true, the other is false, the whole expression is true. When one is false, the other is true, the other expression is true. The whole expression is true. In any other case, it has to be false. So, let's have a look at how we can walk through this code, okay? I'm not drawing the truth table, but I'm doing exactly the same thing by hand by annotating the diagram, okay? My first conditional, if it's true, I look at my second term in the condition. If it's true, then both of them are true, I display KO. If the first one is true, but the second is false, then they have different truth value. I display OK. If the first one now is false, the second one is true, I display OK. They are different. If the first one is false and the second one is false, I display KO. They have different truth value. Okay? One of the advantage of having videos like this is that you can of course rewind my explanation and you can take your time through it, okay? I'm going a little fast here because as you are going to realize when you review the slide, this part is really analogous to the previous, okay? Those 3 examples are really analogic to one another. And we are pretty much done now with everything I wanted to cover about conditional expression. So a couple of words of advice on how to work with this lecture and this module. Everything we covered in this lecture, rather abstract, rather generic. I'm trying to teach you to program in any language. I'm going to try to give you really the building blocks, okay? Once you are done listening a couple of times to this lecture, reworking your way through the slide, etc., make sure you understand everything. Make sure you ask questions if you don't understand everything, and I refer you to our Getting Started introductory lecture, in which you will find all the recipe to work in this online class and how to post questions and what you are expected to do every module as far as posting question goes, etc. So I really refer you to that if you didn't take the time yet to go through it. And once you are okay with the slides, I invite you to move on to the hands-on practice, the hands-on learning, through the learn by programming exercise, which each have a live coding solution, which allows you to learn by another way, learning by watching someone else solve problem and using all of those things that we describe in a rather conceptual and theoretical way in the lecture. And I think we are done for this particular lecture.